Okay, let's move on to example number 2. So this is another classic soil weight and volume relationship problem. We have the unit weight of the soil, 120 pounds per cubic foot. We have the porosity of the soil, 0.26, and we know the soil is fully saturated, and asking for the dry unit weight of the soil. So again, you can pause the video and try to work on the problem for a couple of minutes, and we'll be back. Okay, so now we're back. First of all, let's try to summarize all the givens. We have the gamma is 120 PCF. We have the porosity. You already use a small letter n to denote the porosity is 0.26. And we know the soil is fully saturated. And the question is, what is the gamma D? Okay, so first of all, let's try to again refresh our memory about of all the basic definitions of all those parameters. If you can remember all those parameters, you can always try to refer to the reference manual. But again, it's considering you only have a little time to solve all those problems, so it's not a bad idea to try to remember some of the very basic uh, definitions. For example, the unit weight, that would be the total weight of the soil over the total volume of the soil. Porosity definition is the volume of the voids over the total volume. And saturation, don't really need this here, but the definition of saturation is the volume of the water over the volume of the voids. And the dry unit weight is the weight of the solid over the total volume. So try to solve this. Again, it's always a good idea to plot the three-phase for the soil. Kind of a convenient thing for this problem is that we know it's fully saturated, so there's no air, so we don't have water, and we only have solid. So basically, we're talking about two-phase. So based on all those givens, it's a good idea to assume that your total volume is 1 cubic foot. Remember, this is a only assumption. So doing assumptions sometimes is pretty hard, but I think the more you do it, the more comfortable you would feel that which parameters should be considered as a unit. So there's no better way of mastering the skills of choosing the right parameters for the assumption. But the more you practice it, I think the better you would be. So for this case, if you have the total volume assumed to be 1 cubic foot, then we can take advantage of the porosity over here, because you would know immediately that the volume of the water would be 0.26 cubic foot. But you might want to ask, hey, in this equation over here, we're talking about the volume of the voids. That's absolutely right. But you don't really have any air because the soil is fully saturated. So all those volume of the water, all the volume of the voids will be occupied by the water. So the volume of the water will be 0.26. And we know that the total volume is 1, so the volume of the solid is basically 1 minus 0.26. So we have 0.74. again, you don't really need this 0.74 over here, but I just gonna put it there. The reason why you don't need the 0.74 is that you don't really know the specific gravity, so you can't really cross the bridge from the volume side for the solid. Come to the left. Okay, so coming back to another given, which is this gamma over here. We know the gamma is 120 and the total volume is 1 cubic foot. So we would know that the total weight would be 120 pounds, right? And then the question is, to find out the gamma D, basically we already know this is 1. If we can find out the weight of the solid, then we're good. But as I just said, although we know the volume of the solid, but we don't know the specific gravity of the solid, so we can't really go through this cross from the volume to weight. So this is no good. But we do know the volume of the water so that we can take advantage of the gamma water, which is 62.4 PCF, and to come up with the weight of the water. You have 0.26 cubic foot of water, and you know the unit weight of the water is 62.4. So the weight of the water would be 0.26 cubic foot times 62.4 pounds per cubic foot. That would be 16.2 pounds. So, and you already know the total weight, which is 120. So you can just use that 120 subtracted by the weight of the water. That would give you the weight of the solid. So we have 103.8 pounds. And with that, our gamma D would be 103.8 pounds over the total volume, which is 1 cubic foot. So we're looking at a dry unit weight of 103.8 PCF. So that would be our answer. And oops, sorry about that. And then 103 is the right answer. Okay, so that's pretty much about it for problem number 2.